You've probably heard the recent medical fad of how blue light from your monitor is going to destroy your eyes and kill you, or something along those lines. And also, if you've been to your optometrist lately, they may have recommended you a special coating be put on your glasses that blocks, or more accurately reflects, a super dangerous blue light. Anyway, I don't really think that these glasses do very much at blocking blue light, but before I start shoving my logic down your throats, I want to point out that I could debate whether blue light will or will not hurt you, but when I read up on that, there were conflicting articles and many references to studies. I just don't want to have to go through that. So let's leave that up to the doctors to figure out, and instead see how valid these glasses are at blocking blue light. To begin, let's take a look at the glasses in question. First impressions are pretty good. If you tilt the glasses an angle, you can see the blue light blocking coating they tell you about. And if you look through the glasses, they're completely clear, which is probably an upside for many people who don't want to be ridiculed for wearing those bright yellow glasses. The coating was also highly recommended by an optometrist, for only $20 extra, of course. So it seems pretty legitimate, right? Well, here's the part that doesn't sit right with me, which is that they look to be completely clear. Well, what's the problem with that? They're supposed to be completely clear. To understand my problem, let's take a look at how your monitor creates colors. It really only emits 3 colors, red, green, and blue. And by mixing them in different amounts, it can trick your eyes into seeing a wide range of colors. A simple way of seeing this is to put a small drop of water on the screen of your phone or computer monitor. In short, to make white, it mixes red, green, and blue in equal amounts. Since these glasses claim to block out blue light, let's see what happens when we take the blue component from white that is formed with this method. We get yellow. Therefore, these glasses should be yellow, or at least tinted, since it's physically impossible for them to block out a significant portion of blue light and still be clear. But it wouldn't be very scientific to claim this without testing it first, so let's test it. I intend to test 3 glasses in total. Regular glasses, blue light blocking glasses, and these orange safety glasses, as well as no glasses and this piece of cardboard as controls. As a general overview of what I did, I have a blue LED that shines at a light sensor. Then I have an Arduino microcontroller that checks the value of the light sensor and relays that information back to the computer. During testing, the glasses will be placed between this gap, and the whole setup placed in a shoebox for darkness. Now let's get technical. Real technical. If you don't want to hear that for some reason, then you can just skip to the time on the screen. You've been warned! The light sensor I'm using is a photoresistor, because, well, that's what I had laying around. If you've messed around with Arduino and photoresistors before, you've probably used the classic way of measuring the resistance of a photoresistor, which is to create a voltage divider with it, and measure the voltage with an analog pin. However, the resolution of the Arduino's ADC is only 10 bits, and since we probably won't be using the whole range, we really won't be getting that much resolution. A fix for this would to just get a higher resolution ADC, but I don't have any of those laying around. I'd rather have a more creative solution. Instead, I'm going to use the iconic 555 timer as a monostable multivibrator. Then we can have it arranged like this with the photoresistor R1 and R2 charging up C2. The purpose of R2 is to make sure that we have a minimum pulse length when R1's resistance is very low. On the Arduino side of things, pin 9 outputs a 32Hz square wave to pull the 555 timer, and pin 10 is used to measure the output state of pin 9. When pins 2 and 4 of the 555 timer are high, it will give us an output pulse which has a length determined by this formula. Knowing the length of the output pulse and the value of C2, we can easily infer the resistance of the photoresistor. The advantage of this method is that we can get a precise and accurate resistance measurement. After getting that all set up, I wrote some real quick code to tie it all together. The Arduino just sends the computer the time measurement of the pulse in microseconds, which I can load into Calc. The time measurement then can be converted into resistance with this formula. However, the resistance to light intensity curve of a photoresistor is not linear, and therefore will need to be scaled in order to give a more accurate representation of the data. Luckily, for calibration purposes, an LED has a roughly linear current to light intensity curve. To gain calibration points, I incrementally change the LED current and measure the resistance of the photoresistor. Next, I popped those values into Calc and made a graph of it. Then I fitted a power trend line onto it and got the function. I can then use that to convert the resistance values into an equivalent LED current. Furthermore, I can use the no glasses and completely block control, the cardboard, to convert the equivalent LED current into a percentage of blocked light. Phew, still with me? Good. Let's take a look at how they did. Just regular glasses blocked out 5% of the light, but blue light blocking glasses blocked out 11% more than regular glasses at 16% of the blue light blocked. They actually did something. Probably right now you're thinking, at the beginning of the video you just said that they couldn't work, but now the results show that they do? I just wasted 5 minutes and 36 seconds of my life! Okay, I was wrong. No, you still can't block out blue light with completely clear glasses. However, that's the thing, they're not completely clear. Sure, they may not look tinted, but let me demonstrate something. These glasses block out 16% of the blue light. Therefore, let's see what happens when I take out 16% of the blue component in this RGB color mixer. It's yellower than pure white, but it's not very noticeable. And if I hold up the glasses onto a white section of the screen, we can see that they're about the same color. And after doing some testing with this color mixer, 16% is about the maximum percentage of blue light you can block before it becomes highly noticeable. This, coupled with the fact that you'll be wearing them and not have something to reference this color change, makes them seem pretty clear. But 16% of the blue light block seems like quite a bit not to notice, so why didn't it make a larger color change? Well, that has to do with a funny quirk of the human eye, which is that it does not respond linearly to light intensity. Likewise, if I turn the blue down a bit further, you can see a large color difference. Though this does make these glasses invalid as night glasses, which are supposed to block out the blue light and help you sleep. This is because your brain still evaluates it as being the same amount of blue light, and thus the only effect would be a placebo. Which might be what you want, I'm not going to argue with that. Overall, in my opinion at least, 16% of the blue light blocked is not all that much. Due in part to the fact that regular glasses already block out 5% of the blue light. To further support this, let's compare these glasses to the orange safety glasses I talked about earlier. They blocked out 98% of the light. I'm not really sure if they blocked out that much blue light, but then again the human eye is logarithmic, and I estimate the value is not an order of magnitude off. I expect the yellow computer glasses to perform about the same. Therefore, we can take away that the orange safety glasses more or less beat the blue light blocking coating by quite a bit. And I didn't even mention that there are now free apps or even built-in settings on your smartphone or computer that can reduce the amount of blue light that your screen emits, which will work just as good or even better and won't cost you a dime. So, in conclusion, the blue light glasses are not a complete scam if you believe that blue light is going to damage your eyes, and you're fine with them only blocking out a small portion of blue light, and you'd rather spend your money on glasses instead of just changing a setting or downloading an app. On the contrary, if you're immensely worried about harming your eyes, I can recommend a welding helmet.